So today we will discuss the basic property of Kepler potential. So this is a very nice potential, and if we will talk about force, that is inverse square force, and Coulomb potential is also behaving like this. Kepler potential is also same property they have. So let's try to do it, try to understand the whole thing first analytically, and after then we will use the mathematically, we will also go for mathematical analysis. We will just try to understand each and every step of the particular potential, that is Kepler potential. So if I am talking about Kepler potential, the potential VR is nothing but minus K upon R. And what will be force? Anybody can tell me what is force?
minus del V over del R.
हाँ, तो क्या आएगा वो तो बताओ.
K upon R square.
Again, this is wrong. So deliberately I am asking this question. So that value is minus K upon R square. Okay? Because you have to doing the calculation minus del V upon del R. Are you getting my point? So it's a very interesting. मैं जितनी बार क्वेश्चन पूछा हूं अभी तक पिछले 15 सालों में, हर बार किसी ने गलत आंसर दिया है. Okay? So always try to go for this. This is minus K upon R square. So this is your force, and this is inversely proportional to R square. So always keep in mind. Okay. So now you can see the whole idea is that you can use angular momentum as a parameter, isn't it? So you are just solving the problem for a fixed value of angular momentum, for a given value of angular momentum, because it is conserved in nature. And it is very easy to change energy. So we can change energy by keeping our angular momentum always fixed. If I want to go for one orbit to another orbit, so obviously we have to change energy. But in this whole process, what we will do, we will just try to keep our angular momentum constant. This is the whole idea of satellite maneuvering or all this particular thing. And how you are doing this thing practically is the real challenge, that you are changing energy but keeping your angular momentum fixed. This is the very big challenge in all this particular analysis. Okay, but theoretically we can do it. So what I have, J is the angular momentum, and which is constant, so we can use J as parameter. Sorry, parameter. And obviously mass is always given. So what you have basically a V effective. So what is your V effective? The V effective is basically J square upon 2m R square minus K by R. So this is our V effective. So if this is my V effective, let us try to plot V effective versus R. And the plot is very interesting. So this is all about V effective versus R. So for the smaller value of R, this is proportional to 1 by R square, and this is proportional to R. So obviously this one is the this one is the faster than this one, isn't it? What is meaning of that? Meaning of that, if I will plot it separately, this one and this one. So suppose I am plotting J square by 2m R square, and I am keeping J square upon m, and K is equivalent to each other in a number. So you can plot something like this. Okay. And if we are going for this particular value, this is proportional to R. So this will be decreased little bit slower. So if we are plotting it separately, this kind of thing is there. But if we are going to plot it together, then look at what is going to happen. V effective versus R is nothing but something like this. Are you getting my point? V effective versus R is something like this. This will just try to take up of this one very fastly, and finally at the higher value of R, this will be not dominating, this is going to dominate. So you have this kind of situation. Everyone is comfortable? And now this is my V effective versus R, and this is very famous potential. This is very famous potential. And you can see we can have different type of orbits. So for this particular energy, suppose I am talking about energy E naught, this particular energy, what is the nature of orbit? Circular.
Circular.
Okay. So this is circular in nature of orbit. And for this particular energy, what can we, suppose my energy is negative, what can be nature of orbit? Elliptical. And for energy 0 and more than 0, we have unbounded orbit, isn't it? We have unbounded orbit, you can see. And we can also find the value of E naught by using the concept of V effective. This is nothing but the radius of circle R naught, and this R naught is also identified as what? Stable equilibrium point. So R naught is nothing but radius of circle as well as this is stable equilibrium point. Now let us try to figure it out. What will be value of E naught for the circular orbit? So how we will get it? For energy E, the total energy is half m r dot square plus j square upon 2m r square minus k by r. At r is equal to r naught, my energy E is equal to j square upon 2m r naught square minus k by r naught. The whole challenge is that we have to calculate what is value of r naught. So can we calculate the value of r naught? Calculate कर सकते क्या?
Sir,
How you can calculate it?
del V by del F.
Very good. So we will just go for del V effective upon del R must be equal to 0. And from here we have j square upon mr cube plus k upon r square must be equal to 0. So r naught is equal to j square by mk, isn't it? Am I correct? सही कह रहा हूं?
Yes, sir.
है ना?
Yes.
So you can have, yes, so this will be j square by mk. Now we will put the value of j square upon mk. Last year, I think this was also in your exam. Okay. So when we are going for this particular thing, so we can put r naught as, so this is j square upon 2m. This is j to the power 4. And this is m square, k square minus k. This is j square. And what do you have? And this is basically E naught. And here we have mk. So now, how we can, what will be this value? 1m will cancel. And k square is also there. So here is k square and this j square is also there. So you have m j square k square by 2 minus m k square upon j square. Sorry, upon by 2j square. mk square by 2j square. Am I correct? ठीक लिखा हूं क्या? देख लो एक बार कैलकुलेट कर लो.
Yes, sir.
है ना? And what is this value? This value is minus mk square upon 2j square. So this is value of energy for circular orbit for a Kepler's problem, isn't it? And you can similarly calculate what will be angular frequency for circular orbit, and you can also calculate what will be angular frequency for elliptical orbit. Can you calculate it? कैसे करोगे angular frequency for the circular orbit के लिए?
Del V by del R.
Very good. So omega naught is equal to, you can calculate del V upon del R upon m R naught, and this is at R is equal to R naught. So what is your omega naught? So omega naught is basically del V upon del R. क्या हो जाएगा? That is k upon R square, isn't it? So you have k upon m r naught to the power cube root under. And now you can see omega naught is proportional to or equal to root under k upon m, and this is r naught to the power 3 by 2, minus 3 by 2 actually, not 3 by 2, 3 by 2. And you have something like Kepler's third law kind of thing. Time period is proportional to r to the power 3 by 2. And I can put the value of r naught from here. Put kar sakte na? What is value of r naught? That is j square upon mk. Okay. So you can put the value omega naught, and similarly you can get the value of omega e also. And you will be surprised that omega naught and omega e have same value. आप देखोगे जब आप calculate करोगे in this case. So what is omega e? That is del square V effective upon del r square at r is equal to r naught by m. So you can calculate omega e. Omega e is the angular frequency for which you are doing the basically elliptical orbit, and which is equivalent to small oscillation. So you can find in this case omega e is equal to omega naught. I am just giving you homework to do this thing. This is just a practice problem to you. कर लोगे इसे?
Yes, sir.
है ना? I have done each and everything, so you can do it. Now, I am not interested in omega right now. What I am interested into energy. This is very interesting. So let's try to go for a, and you can see for the negative value of energy, you have either circular orbit, and yes, this is a negative value of energy, and this is the fixed value E naught. Other than all other negative value, you have elliptical orbit, and you can have different unbounded orbit for E is equal to or greater than 0. So this is a use of V effective, we can solve it. Now let's try to solve the problem with the help of differential equation of the orbit. So let's try to go for it. चले वहां तक? यहां तक कुछ पूछना है तो पूछ सकते हो आप. Anyone? Chalo. So let's try to go for differential equation of orbit. And in the last class, I have told you the differential equation of orbit has two purposes. The first purpose is that it will just tell you all about, if you know the equation of orbit, it will just tell you what is the nature of force. And if you know the nature of force, it will tell you what is the equation of orbit. So now I am just going to the second part of this particular thing. So today we have a force that is minus k upon r square. And now we will try to solve the differential equation, and we will see which type of orbit is there. And you have solved some problem into last class also. So let's try to go for this one. And this is very interesting and very nice calculation also. And it will give you entirely different insight to understand the system. Okay. Okay. So what is my differential equation of orbit? Anyone can suggest me? क्या था बताओ? Anyone?
Minus j square u square by m.
Minus j square u square by m d square u upon
d
theta square plus u is equal to f1 by u. है ना?
Yes.
Okay. And what is your FR? FR is minus k by r square. So what is your f1 by u? Minus k u square. So what we will do? We will put it this particular thing in this particular equation. So I will put minus k u square here. So what you will get? Minus j square u square upon m d square u d theta square plus u is equal to minus ku square. So what I can do? I can just equate the coefficient of u square on both sides. हम लोग coefficient use कर सकते हैं, equate कर सकते हैं both sides. Then what you will have? You have d square u upon d theta square plus u is equal to mk upon j square. And now what will happen? You have d square u, d theta square u minus mk upon j square must be equal to 0. Now this is very simple. This is linear in u. So if it is linear in u, you can easily solve it. How you can solve it? You can put u minus mk upon j square is equal to y. And then what you have? D square u upon d theta square is equal to d square y upon d theta square. So what will be solution? D square y upon d theta square plus y is equal to 0. Very famous differential equation, isn't it? क्या होगा इसका solution? I hope everybody have done differential equation chapter, है ना? What is solution?
Y equal to a cos theta.
Y is equal to a cos theta, y is equal to a sin theta, y is equal to a cos theta plus sin theta. कुछ भी हो सकता है ना? And it will depends on initial condition that what is the actual solution. So we have taken deliberately our initial condition such that I have y is equal to something like a cos theta. So if y is equal to a cos theta, what is y? Y is nothing but u minus mk upon j square a cos theta. And what is your u? U क्या होगा? You have j square upon mk plus a cos theta. And what is your u? 1 by r is equal to j square upon mk plus a cos theta. You can take j square upon mk common and take it in the right hand side. So what you will get? You will get j square upon mk by r must be equal to 1 plus a mk j square cos theta. Isn't it? And I can write this whole equation something like, so I think this is okay. Okay, good. What I can do, I can write this equation as L by R is equal to 1 plus E cos theta. L is positive quantity. E is also positive quantity. And I can merge this A constant into this constant into constant is some constant. So I have taken deliberately this particular equation. What is this equation? ये किस चीज का equation है?
Conic section.
Conic section. So this is equation of what? Conic section.
Sir, right side में calculation error है क्या?
किस
या
side में?
U equal to ये जो लिखे हैं U equal to J square upon M, वो MK upon J square होगा. ठीक है.
बिल्कुल राइट में
ये वाला?
हाँ.
एक मिनट.
तो ये
Oh, sorry.
U equal to
U is equal to mk upon j square. Very good. Good. So ये भी क्या हो जाएगा? mk upon j square. तो यहाँ पर j square by mk ही होगा ना? Good. यहाँ कैसे ठीक हो गया? Okay. दिमाग में कुछ और. ये सही लिखा हूं? यहाँ पर गड़बड़ है ना? Isn't it? So mk upon j square कॉमन लेंगे. So this will be j square upon mk. ठीक है? क्लियर है ये? ठीक लिखा हूं? Just check it. सौरभ ठीक है?
Yes, sir.
Okay. Now, anyway, so I am interested into this part. So what is this L? इस L को क्या कहते हैं? Anyone? अगर कोनिक्स पढ़े हो तो क्या कहते हैं? L को क्या कहते हैं? Latus rectum. Latus rectum क्या बताता है? Mainly size के बारे में आप कह सकते हो, but it will tell you some ratio, है ना? So mainly it will define size. And what is E?
eccentricity.
एसेंट्रिसिटी। ये क्या बताता है, बताइए?
सर कॉनिक सेक्शन पता चलेगा कैसे है?
शेप के बारे में, है ना?
Yes, sir.
एसेंट्रिसिटी, शेप और एल साइज। ओके, गुड। नाउ अब जरा सा देखते हैं, हम लोगों ने दो तरह के चीजें देखा, एक तो हमने वी इफेक्टिव देखा और इधर हमने मैथमेटिकली सॉल्व किया चीजों को। दोनों को मर्ज करते हैं और फिर देखते हैं क्या मिल रहा है। यहां तक क्लियर है आप लोग, एवरीवन?
Yes, sir.
Okay, good. So now let's try to go for next part. And this is very interesting analysis. और कई बार सिर्फ इसी पर्टिकुलर एनालिसिस से कई क्वेश्चंस आ गए। मेनली जैम और गेट के एग्जाम में तो 100%, ठीक है। नेट में थोड़ा सा लेवल डिफरेंट वे में जाता है, मेनली इफेक्टिव पोटेंशियल का यूज वहां ज्यादा होगा, बट यू कैन यूज दिस पर्टिकुलर थिंग। ओके, चलो, सो लेट्स ट्राई टू डू द एनालिसिस पार्ट। क्या किया है, कैसे हो सकता है और क्या निकल सकता है, ये सारी चीजों को हम देखने की कोशिश करते हैं, है ना? वेरी गुड। व्हाट वी हैव, सो हियर वी हैव effective potential and this is my effective potential, and here we have equation. Okay, now you can see, if I am talking about this particular value of energy and this energy is E naught, और ये एनर्जी कितनी निकल करके आई थी, -mk² अपॉन 2j², यही निकल के आया था ना? Yes. So now if this energy is E naught, the shape of orbit is what? Circular. So here the energy is equal to E naught, and which is equivalent to -mk² upon 2j². The eccentricity of a orbit is what? 0. Circular orbit का eccentricity क्या होता है? Obviously 0. And what is shape? Ellipse. Sorry, that is circle. That is circle. And now if your energy is between E naught to 0, what will be your eccentricity? इस एनर्जी की बात कर रहा हूं, something like this energy E. What will be energy? What will be shape?
Elliptical.
Elliptical.
E is
Very
less
good.
than 1.
E is less than 1 and greater than 0. Okay. E is equal to 0 is a special case of ellipse, which is known as what? Your circle. And now if E is greater than equal to 0, then eccentricity, then the shape can be what? Either parabola or hyperbola. So you have E is greater than equal to 0. When your E is equal to 0, this is a special case for parabola. E is equal to 0 is parabola, and E is greater than 0 is hyperbola.
Sir, E is greater than or equal to 1.
Sorry, greater than 1. Sorry, greater than 1. So this is greater than 1. So E is greater than equal to 1, then E is greater equal to 1, parabola is greater than 1 is hyperbola, and the nature is parabola and ellipse. Now you can see, here we are just changing the energy, we are shifting into one orbit to the another orbit. यहां हम क्या चेंज कर रहे हैं? एनर्जी चेंज कर रहे हैं। और मैथमेटिकली हमें क्या चेंज हो रहा है? यहां तो एनर्जी चेंज हो रहा है, मैथमेटिकली क्या चेंज हो रहा है? कि एक ऑर्बिट से दूसरे ऑर्बिट में जा रहे हो। इसेंट्रिसिटी, वेरी गुड। इस इक्वेशन में हम इसेंट्रिसिटी चेंज कर रहे हैं, यू कैन सी We are changing the eccentricity. We are changing from one orbit to another orbit. And here we are changing the energy. That means we are changing from one orbit to another orbit. That means there must be some relationship between eccentricity and the energy. होना चाहिए. So let's try to find this particular relationship for the Kepler's problem. और ये सारा हम किसके लिए कर रहे हैं? Which type of potential?
minus k by r.
माइनस के बाई आर, विच इज नॉट सेंट्रल फोर्स. सेंट्रल फोर्स में कई तरह के पोटेंशियल हो सकते हैं. अभी जो हम काम कर रहे हैं दैट इज ओनली एंड ओनली फॉर व्हाट? माइनस के बाई आर, दैट इज केपलर्स प्रॉब्लम और कूलम्स प्रॉब्लम. कूलम्स के साथ भी आपका यही चीज होगा. ओके
Yes, sir.
ओके, लेट्स ट्राई टू गो फॉर दिस.
सर कूलम्स लॉ भी सेंट्रल फोर्स तो होता है सर.
बिल्कुल बिल्कुल, कूलम्स लॉ भी सेंट्रल फोर्स है. तो क्लास वहीं से शुरू ही किया था, है ना? आप अगर आपको याद हो क्लास कहां से शुरू किया था, फर्स्ट एग्जांपल ही हमने कूलम्स लॉ दिया था, है ना? कूलम्स फोर्स, कूलम्स लॉ ने कूलम्स फोर्स. ओके, कूलम्स फोर्स इज q1 q2 by 4 pi epsilon naught r. Okay, so what we have L upon R is equal to 1 plus e cos theta, and this derivation is very interesting और आपको थोड़ा सा ध्यान देना पड़ेगा. Now what is your theta dot? J upon mr square. Good. And what is your L? J square upon mk. ये सारा इंफॉर्मेशन हमारे पास है. Okay, let's try to go for a value of energy. What is this particular value? Half m r dot square plus j square upon 2m r square minus k by r. Everyone is comfortable? So what is our duty? Our duty here is that we want to write energy as a function of eccentricity. यही तो लिखना चाह रहे हैं. So how you can approach it? आप कैसे approach कर सकते हो? So here I can find r dot from here, I can find r from here, and I will put this particular equation. So let us see how we can use this particular calculation. This is very interesting. So here minus L upon R square R dot is equal to minus E sin theta, theta dot. Yes or no? And I can put theta dot is equal to J upon MR square. So minus L upon R square R dot is equal to minus E sin theta J upon MR square. So this r square is cancelled. This negative sign is cancelled. So I can put r dot is equal to E j sin theta by ml. लिख सकते क्या? Yes or no?
Yes, sir.
Yes. So let us try to go for writing this particular thing. So this is half m e square j square sin square theta by m square l square. देखते रहना, मैं कहीं कुछ गलती तो नहीं कर रहा हूं. j स्क्वायर बाई 2m वहां से लिख सकते हैं 1 बाई आर स्क्वायर की जगह पर क्या हो जाएगा? 1 प्लस e cos theta whole square, sorry this is r, okay, r square, that is l square. सही लिखा हूं? माइनस k अपॉन l 1 प्लस e cos theta 1 बाई आर की जगह पर डायरेक्ट लिख रहे हैं. ठीक है?
So
Yes.
one L will be there, na?
लिखा तो है k बाई l,
Yes, yes.
है ना? चलो यहां से ये एम कैंसिल कर दे रहे हैं. आई कैन टेक जे स्क्वायर बाई 2ml स्क्वायर कॉमन. ले सकते क्या? व्हाट इज फर्स्ट इक्वेशन? फर्स्ट में क्या होगा? ई स्क्वायर जे स्क्वायर भी रहने देता है ना. सो आई कैन टेक half ml square common. Sorry. So I am just taking half ml square common. So this is e square j square sin square theta. First term is okay with आपके लिए ठीक है. Second term is j square 1 plus e cos theta. Third term is k into l and 2m is also there. This is 2mkl 1 plus e cos theta. देख लो यहां तक ठीक लिखा है.
मिडिल टर्म में 1 प्लस ई कॉस थीटा स्क्वायर हो.
Yes, sir.
ओके, मिडिल टर्म में स्क्वायर होगा. थैंक यू. यहां तक ठीक है. चलो, अब यहां पर ये एल स्क्वायर को बाद में चेंज कर लेंगे. ओके, इस वाले एल स्क्वायर को लिख सकते हैं जे स्क्वायर बाई एम के. ठीक है. ओके, नाउ लेट्स सी व्हाट इज गोइंग टू हैपन. सो दिस इज योर ई, दैट इज हाफ एम एल स्क्वायर e square j square sin square theta, and from here you have j square e square, sorry, second term is j square e square cos square theta, and cross term 2e j square cos theta, and here minus mk is cancelled, j square minus 2e j square cos theta. ठीक लिखा हूं? जस्ट चेक इट. कहीं कुछ भी गड़बड़ होगा तो आंसर बहुत अजीब सा आ जाएगा, है ना. क्या क्या कैंसिल हो रहा है?
So -2j square.
हाँ, -2j square. ओके, दिस इज -2j square. गुड. ओके, क्या क्या कैंसिल हो रहा है? ये दोनों कैंसिल हो रहा है और ये दोनों मिलकर क्या बना दे रहा है? जे स्क्वायर ई स्क्वायर, है ना. एक बार जरूर करना चाहिए कैलकुलेशन. हालांकि फॉर्मूला याद करने से भी आपका काम चल जाएगा.
J square भी कैंसिल हो रहा है सर.
ई स्क्वायर और जे स्क्वायर -2j स्क्वायर क्या हो जाएगा आपका?
Minus
-j स्क्वायर. ऐसा कुछ आ रहा है?
Yes, sir.
ओके, और फिर से एल को हम जे के टर्म में लिख सकते हैं, है ना. सो दिस कैन बी रिटन एज हाफ एम. एल को क्या लिखेंगे? जे टू द पावर 4 एम स्क्वायर के स्क्वायर, और फिर से जे स्क्वायर को कॉमन ले रहे हैं, एंड दैट वैल्यू इज इक्वल टू ई स्क्वायर -1. ठीक लिखा है? देखो तो. Okay, I am using this space. So just calculate it whether E is equal to something like, so what do you have? 1 plus 2E j square upon mk square root under. Just check it. 1 इधर आ जाएगा. पहले तो ये इसके साथ मल्टीप्लाई हो जाएगा. 1j square is cancel, m is cancel. So this will come downward. Just check it whether you are getting this equation or not. आ रहा है क्या?
Yes, sir.
आ रहा है? Good. So now you can see this eccentricity has direct relationship with energy. And now look at how this thing is going to match with our analysis. हमने जो चीज लिखा है उसके साथ ये कैसे एनालिसिस में मैच कर रहा है. लेट्स ट्राई टू गो फॉर इट. यहां तक क्लियर है? चलो, हमारे पास क्या था वो जरा देखते हैं. So everything we are just going to discuss here. Again we are plotting V effective. So this is my V effective. Okay. And here my eccentricity is equal to root under 1 plus 2e j square upon mk square. And now we will discuss different type of shape. So for E is equal to 0, sorry, eccentricity is equal to 0. What do you have? Which type of orbit?
Circle.
Circle. Very good. And what is energy? जरा बताओ तो energy क्या मिल रहा है? जिसे हम E naught भी कहते हैं. This energy is E naught. What is that particular E naught? Put value of energy eccentricity is equal to 0. You will get energy is equal to minus mk square upon 2j square. Exactly same thing. Are you getting from here?
Yes, sir.
Exactly same thing. ठीक है ना? Okay. Now, if your eccentricity is between, 0 to 1, what should be your nature of orbit? Ellipse. The nature of orbit is ellipse. And now you can see now this must be fraction. This eccentricity must be fraction. That means this energy have to be negative value of energy. Yes या no? और लेकिन नेगेटिव होने के साथ साथ ये इतना कम ना हो जाए कि 1 से 1 माइनस समथिंग इज इमेजिनरी. ऐसा नहीं होना चाहिए. So there are fixed value. So what should be the minimum value of E? The minimum value of E is equal to this one. You have always more energy than this one. So your energy E must be between minus mk square by 2j square to 0. And you have elliptical orbit. Are you people happy? Yes or no?
Yes, sir.
And now E is equal to 1. What do you have?
Parabola.
Parabola. So E is equal to 1. You have parabola, which means your energy is equal to E is equal to 1 is parabola, means your energy is equal to what? 0. And now, if E is greater than 1, what you have? You have hyperbola and your energy must be positive. So now you can see whatever we have analyzed, we can discuss from this particular equation or this particular expression, not equation. This is something expression. So this is case of ellipse. This is case of parabola. And this is case of what? Hyperbola. This is E is greater than 0. This is E is equal to 0, isn't it? And here E is between E naught to 0. Look at each and everything is there. And what is my L by R? What is my equation of orbit? 1 plus E cos theta. So this is my equation of orbit. Now you can use this chart to understand your Kepler's system. Everybody is comfortable? चलो. So let's try to go for one very interesting problem. उसको जरा करने की कोशिश करते हैं. बढ़े आगे क्या?
सर ये इलिप्स वाला केस समझा दी सर, थोड़ा सा समझ में नहीं आया एनर्जी.
कहाँ प्रॉब्लम हो रहा है ये बताओ.
सर एनर्जी सर माइनस एम के स्क्वायर अपॉन 2j स्क्वायर सर कैसे आया इसका सर इलिप्स में सर?
इलिप्स में ये कैसे आया
यस सर।
भाई? ये फ्रैक्शन होना चाहिए, उसके लिए इसे नेगेटिव होना पड़ेगा। बोलो हाँ
सर।
या ना।
यस।
लेकिन अगर ये इतना नेगेटिव हो जाए कि 1 से भी, कि ये पूरा चीज इमेजिनरी हो जाए, तब तो ऐसा नहीं होगा ना।
नहीं सर।
ई की वैल्यू 0 से तो ज्यादा होनी चाहिए।
यस सर।
तो 0 होने के लिए क्या वैल्यू चाहिए? ये चाहिए।
यस सर।
जब 0 होने के लिए ये वैल्यू चाहिए, तो इससे ज्यादा होगा तभी तो ये वैल्यू आपका फ्रैक्शन होगा, अदरवाइज वो वैल्यू इमेजिनरी हो जाएगा।
ओके सर।
ठीक है, आप यहां पर खुद करके देखो, ई की अलग अलग वैल्यू पुट करो नेगेटिव में, एंड देखो किसके लिए फ्रैक्शन आ रहा है। ओके, चलो। यहां तक क्लियर है? चलो, so let's try to go for a very interesting problem. Just a minute. So what we have potential. This is very interesting potential. VR is equal to minus K by R plus H upon R square. K is greater than 0. H is greater than 0. ठीक है? VR is equal to minus K by R plus H upon R square. So K is greater than 0 and H is greater than 0. So we have to write the equation of orbit. And you will surprise that equation of orbit is something like a Kepler's orbit. Look at here. So what is your FR? What is your force? क्या होगा force? Minus, so force is nothing but minus del V upon del R. And that value is equal to minus K upon R square plus 2H upon R cube. Everyone is comfortable? ठीक है ना?
सर ये माइनस के बाई आर स्क्वायर बताना एक बार कैसे आ गया?
अरे भैया, डिफरेंशिएट करो इसको।
सर मेरा नेगेटिव साइन पॉजिटिव में जा रहा है।
अरे
फिर
पहले डिफरेंशिएट करो इसको, डिफरेंशिएट करो, के बाई आर को डिफरेंशिएट करो।
-1/r²।
हो गया? अब फिर से माइनस लगाओ।
यस सर, पॉजिटिव हो गया फिर।
हाँ, अरे भाई, पहले आप इसको डिफरेंशिएट कर रहे हो, ये पूरा कैलकुलेट करना है ना।
यस सर।
पूरे को डिफरेंशिएट करो, क्या होगा?
-k/r² आएगा सर।
ये होगा ना माइनस के बाई आर स्क्वायर।
यस सर, यस
तो
सर। थैंक यू सर।
चलो, सो व्हाट विल बी एफ 1/u? दैट इज माइनस के यू स्क्वायर प्लस 2h u क्यूब। ठीक है? And now let's try to go for your equation of differential equation of orbit. So minus j square u square by m d square u d theta square plus u is equal to f 1 by u. So minus j square u square upon m d square u d theta square plus u is equal to minus ku square plus 2h u क्यूब। तो हम लोग क्या कर रहे हैं, u स्क्वायर के कोफिशिएंट को दोनों तरफ इक्वेट करेंगे। ठीक है? So what you will get? D square u upon d theta square plus u is equal to, so this will be km by j square plus, or sorry, this will be minus 2hm j square u. ठीक लिखा हूं? Yes या no? Okay. So I will take u common and I can rearrange this equation d square u upon d theta square plus 2hm j square plus 1 u minus km j square must be equal to 0. ठीक है?
Yes, sir.
Yes, sir.
Very good. Now this is linear term and this is constant term. So constant term का कोई भी effect नहीं होगा. I can put this whole thing is y. जैसे last term में किया था, है ना? So whole thing is y. क्या हो जाएगा ये? 2hm j square plus 1 u minus k upon m j square is equal to y, and you have d square u upon d theta square 1 upon must be equal to 1 upon 2h h cut nahi h 2hm j square plus 1 d square y d theta square. ठीक लिखा हूं? ये तो कांस्टेंट है, तो वो क्या हो जाएगा? 0 हो जाएगा, है ना? So what is your final equation? The final equation is 1 upon 2hm upon j square plus 1 d square y d theta square plus y must be equal to 0. लिख सकते हैं ऐसे? And your equation is d square y d theta square plus 2hm plus 1 upon j square y must be equal to 0. And I can put this thing as a omega or something omega square because everything is positive, isn't it? Put कर सकते हैं इसे? So you have d square y d theta square plus omega square y is equal to 0. What is solution of this equation?
Omega t.
Omega t. ये क्या solution है?
Omega
A sin omega t.
हाँ?
y is equal to a cos omega theta plus b sin omega
हाँ.
theta.
Omega theta b sin omega theta, है ना? So I can take cos term such that, and what will be sin? It will be sin or cos depends on initial condition. So that will depend on initial condition, but I am taking deliberately for cos solution. So what is your solution? Y is equal to something a cos omega theta. And what is your y? Y is something, this value is equal to omega square, है ना? कुछ यही तो है? This is omega square. What is y? Omega square u minus km upon j square is equal to y, and that value is equal to what? A cos theta. And you can have omega square by r minus km upon j square is equal to a cos theta. So this will be your solution, and this is more or less equation of conics, isn't it? कुछ phase part है, कुछ constant term है, but more or less these are nothing but equivalent to what? Equation of conics. 1 by r is proportional to theta, cos theta. That is all about we are discussing. और other term को आप constant को 1 मान करके आप check कर सकते हो. Only this term is extra term is which is going in this direction, है ना?
Yes, sir.
है ना? So you can see. So it will depends on potential. which type of orbit is there? Obviously, this type of question can come either in JEST exam or TIFR exam, not any other examination. But you have to work with this type of equation, है ना? आप इस तरह की equation से easily काम कर सकते हो. So you can see we can use the differential equation of orbit to analyze the thing, and we have learned in the Kepler's potential that each and every type of orbits can be possible. There may be bounded orbit, there may be unbounded orbit, there may be parabolic, elliptical, hyperbolic, circular, all kind of orbit is possible, depends on what is its energy. And if you know the energy, you can write the eccentricity theoretically. But in all process, in all maneuvering of the one satellite to the another satellite, planet have its fixed orbit, but satellite can be maneuver from one level to another level. You have to keep your angular momentum constant. Are you getting my point?
Yes, sir.
है ना? So you have to keep your angular momentum constant. अब वो कैसे constant रखोगे? That is matter of technology. And यहीं पर सबसे ज्यादा effort लगाना पड़ता है. Okay? So this is from my side of Kepler's problem. Tomorrow we will go for a Kepler's law actually. That is 3 law. So first we will do for Kepler's law, then we will do some problems, and I think tomorrow or day after tomorrow I will just completed this particular topic. ठीक है?
कुछ चीजें पूछनी है, बंद मत
हाँ
करिएगा।
बताओ.
ये कंडीशन क्या, व्हाट इज द कंडीशन फॉर सेंट्रीफ्यूगल बैरियर?
सेंट्रीफ्यूगल बैरियर का कंडीशन क्या होगा तुम बताओ?
ये क्वेश्चन में पूछा हुआ था।
हाँ, सेंट्रीफ्यूगल बैरियर का मतलब क्या कि बाउंडेड से वो अनबाउंडेड की तरफ चला जाए, यही तो है.
यस सर।
जब तक वो बाउंडेड है तब तक उसमें सेंट्रीफ्यूगल टर्म तो मिल ही रहा है ना. इवन इलिप्स भी है तो उसमें सेंट्रीफ्यूगल टर्म तो मिल ही रहा है तुम्हें.
यस सर।
तो जब तक आपका बाउंडेड है सिस्टम तब तक बाउंडेड है और वो रोटेट कर रहा है तो सेंट्रीफ्यूगल टर्म मिल ही रहा है. सो आपका बाउंडेड से जैसे अनबाउंडेड में जाने की कोशिश करेगा, सो दैट विल बी द थिंग. एक क्वेश्चन है प्रीवियस ईयर में, हम लोग डिस्कस कर सकते हैं इसको. ठीक है?
और एक है वीरियल कुछ करके था,
वीरियल थ्योरम के बारे में बात कर रहे हैं.
इक्विलिब्रियम।
वीरियल थ्योरम के बारे में बात करते हैं. इक्विलिब्रियम वगैरह नाम दे सकते हैं. वीरियल थ्योरम के बारे में बात करेंगे. इसका आप यूज कहीं भी यूज कर सकते हो, क्वांटम मैकेनिक्स में, क्लासिकल मैकेनिक्स में, थर्मोडायनेमिक्स में बहुत ज्यादा. इस लास्ट ईयर जेस्ट के प्रॉब्लम में एक क्वेश्चन वीरियल थ्योरम के ऊपर आया है स्टेटमेक का. वीरियल थ्योरम क्या कहता है? वीरियल थ्योरम विल टेल यू इफ यू नो mainly for the bounded system, if you have bounded system और बाउंडेड सिस्टम में इन जनरल इफ इट इज सेंट्रल फोर्स, देन अगर आपको पोटेंशियल का नेचर पता है तो काइनेटिक एनर्जी का एवरेज वैल्यू और पोटेंशियल एनर्जी का एवरेज वैल्यू के बीच में आप रिलेशनशिप देख सकते हो. और अगर इनका रिलेशनशिप देख सकते हो तो बहुत सारी चीज निकल सकता है ना. जैसे लास्ट ईयर एक स्टेटमेक का क्वेश्चन आया हुआ था, होप आलोक सर इसको डिस्कस भी करेंगे, बट मैं आपको बता देता हूं कि पोटेंशियल एनर्जी दिया है 1 डायमेंशन में mod x to the power alpha. Okay, so what will be value of alpha such that its energy is 2/3 kT, है ना. so 1 डायमेंशन में काइनेटिक एनर्जी की एवरेज वैल्यू क्या होगी फॉर द गिवन टेम्परेचर?
केवीटी बाई एम,
केवीटी बाई टी, है ना. केवीटी बाई 2, दैट इज काइनेटिक एनर्जी इन 1 डायमेंशन, है ना. हर एक
यस
है ना. तो अब वीरियल थ्योरम में अब काइनेटिक एनर्जी की एवरेज वैल्यू आपको पता है. वीरियल थ्योरम का यूज करके पोटेंशियल एनर्जी की एवरेज वैल्यू और काइनेटिक एनर्जी की एवरेज वैल्यू के टर्म में आप इक्वेशन निकाल सकते हो एंड यू कैन सॉल्व द प्रॉब्लम. ठीक है? सो इसका बहुत ज्यादा यूज करते हैं हम अपने चीजों को वेरी फास्टली एनालाइज करने के लिए. ठीक है? और इसका थर्मोडायनेमिक्स, क्वांटम मैकेनिक्स आप देखोगे, जैसे कि हाइड्रोजन एटम में there is some relationship between kinetic energy and potential energy. हार्मोनिक ऑसिलेटर में हमेशा देखो कि काइनेटिक एनर्जी का एवरेज और पोटेंशियल एनर्जी का एवरेज सेम होता है ना. तो इस तरह की चीजें हम देख सकते हैं. ठीक है? वी विल डिस्कस, हम लोग डिस्कस करेंगे इसको. ठीक है?
ओके सर।
ओके, और कुछ?
हाँ, IIT जैम का वो क्वेश्चन नंबर 4 आप देख लीजिएगा, उसके सॉल्यूशन में शायद दिक्कत है।
देख लेंगे उसमें। IIT-JAM का प्रीवियस ईयर का?
IIT जैम का 2013 का है, क्वेश्चन नंबर 4 है।
अच्छा ठीक है, देख लेंगे। ओके चलो, थैंक यू।
थैंक यू सर।